So please come up here. Kirti.
Thank you, Tim, for the kickoff. And I just wanted to add one thing before we start the panel today. We went straight into a lot about the standards data for a whole bunch of different standards that LexisNexis has done a fantastic job on organizing, thanks to Tim and team here. But just very quickly, why it matters, and it's mattering more and more in today's world where global technology standards are not only important for the companies that are in the room today and a lot of consumers and a lot of users. There are, many national strategies are recognizing the importance of these technologies in this global race that we are in for technology leadership. And many of us live, including me now, live in the world of litigation, regulatory challenges that surround these technologies and these standards and intellectual property around them. And I've been in enough conferences, and I'm sure many of you have as well, where we often jump straight into the weeds of the legal and economic and regulatory analysis of these issues, and we kind of go straight past the technology, which is almost exactly, and not even almost, it is basically the foundation and the core. So, we made a commitment when we started organizing this that we're always going to start the day rooted in the discussion on what is the technology. And that's why, economists like me and Tim and others can actually do the right evaluation when it's necessary, when we become fact finders. So with that, I would like to invite my co-panelists with me. Please come on the stage. I see you all, Lorenzo, Irfan, Raj, and Mang. And we'll all get ourselves introduced in a second here. Thank you. I decided to just choose any seats. Please do the same. Thank you. Is that? All right, very good. So in no particular, they chose the order exactly right. Thank you so much. So excellent. So look, we have these experts on the panel with us who can really walk us through the future of wireless technology. So let me do a quick introduction. Mang is the Vice President and Head of IP and Interdigital. Lorenzo Casaccia, he's the Head of Technical Standards and IP at Qualcomm. Irfan Ali, CEO, Team Mobility and IoT at Cisco, and Yavatkar, who is the CTO at Juniper Networks. And a quick story here, by the way. It's this panel is kind of a reunion of sorts. So when we organize this panel, I get this email from Irfan, saying, "Hey, do you remember me? We used to." Lorenzo, Irfan, and I used to attend the same standards meetings almost 20 years ago, and also right there. So we've been buddies attending standards meetings, 3GPP meetings, back in 2005-06 timeframe, and maybe more than that, and traveling the world for those meetings many moons ago, and fighting over technologies. So it's great to be reunited. And with that, I would just like to quickly jump into the panel discussion here. So thank you all for joining us today. And let me start just by asking you, we all use wireless technologies every day. It has changed our lives. You have your phone and your laptop, but more and more in all different kinds of devices. So maybe we start with a quick roadmap orienting us to where we are today in the overall evolution of this technology. Didn't start recently. We've been on this road for a long time, and we're going somewhere. So if you take a kind of a roadmap, can you point us to where we are at? So maybe we start briefly with you, Lorenzo, and anybody please jump in, but I'll call people for facilitating the conversation. Very briefly, how did the Gs evolve? Can you give us a bit of a history tour here?
Yeah, of course, and thank you for the invitation, and good morning, everyone. Thank you to everybody that is attending. Wireless technology, cellular technology, operates in generations, also called Gs, that take place about every 10 years each. And so there is a 10-year cycle which is governed by a few different factors, maybe the most important of which is the global availability of spectrum that is reshuffled or rediscussed on a 10-year time frame. And so, because cellular technology started from regular voice calls long time ago, and that was 2G. And then gradually there was the desire to try to use the same fundamental building blocks to provide data, which went with 3G, and with that you are you go into new millennium around 2099, 2000. And then from there, we went into 4G, which was really a big step in terms of all of the fundamental building blocks, new waveform, new coding, new modulation, new way of architecting a network. And it's where wireless technology started to integrate more with the internet. So with 2G and 3G, of course, internet was really a nascent concept. And voice networks were another thing. They were two separate concepts. With 4G, internet and cellular technology started to merge. And then with 4G, you really had broadband data with mobility. And because of this, phones started to become computers, and phones started to become smartphones when people started to add a second CPU to their phone. And so 4G really was really a watershed moment for cellular technology, where it became more a wireless data enabler and a wireless computing enabler. And then moving 10 years later, we had 5G. 5G was starting around 2015, 2016, and got deployed 2019, 2020. And 5G was a little bit more in continuity with 4G. So, of course, as everybody can see, smartphones more or less have been looking the same since the times of 4G. And the big difference started to be to use those building blocks that enable smartphones to go into other segments. And so you start to have 5G for automotive, 5G for IoT, 5G for broadcast, 5G for satellite, 5G for drones, and on and on and on. Some of these things have come to fruition. Automotive, of course, was mentioned earlier. Some not yet. Some are still at the research stage, some at the incubation stage. But that was the general idea, to take those building blocks and expand. And the same thing will happen with 6G. So 6G will start around 2025. We can expect it will be deployed in 2030, and will continue that curve.
So, yeah, so from, and you skipped 1G, thanks for sparing us that, the analog technologies. But we've come a long way from, the $4,000 brick phone in the early 1980s from Motorola, which used to fit in a car, to where we are, and we are still headed in a direction that's exciting. So Irfan, and that's, that's cellular. That's the cellular story. So Irfan, I'd like to ask you to walk us through a similar Wi-Fi story. We're just, getting started here.
No, thank you, and it's a pleasure to be here in front of you and to be here on in Berkeley. In this is always, being in the business school is always the best campus you can be in. So all of Berkeley looks like this. You just shouldn't look across to the engineering building over there. So, so as Lorenzo was saying, I mean, that kind of the journey that we have had with cellular has been amazing, and the same thing we've seen with on the Wi-Fi side, right? So pretty much we had, from 1997 to 2004, I don't know how many of you kind of remember having to buy that external modem with those little antennas sticking out to get your Wi-Fi connection to your laptop. So from that was, I mean, basically Wi-Fi previously used to, also the other thing, Wi-Fi folks used to have these names like 802.11bgbfn things. It was like, what the heck is going on, right? But then they wisened up because they saw this 2G, 3G, 4G. That's a lot easier. So now Wi-Fi are also called generations now. So they went back and renamed all their kind of Wi-Fi things with generation 0, 1, 2, 3. So essentially what we have is from 1997 to 2004 was very much a laptop-focused kind of Wi-Fi standards, which Wi-Fi 0 all the way to Wi-Fi 4. And then, of course, came the iPhone and Wi-Fi. And essentially from 2008 to 2019 to Wi-Fi 5, which came out, it was essentially cell phones and trying to handle the traffic, which is coming in a lot more over there. And what Wi-Fi started realizing was that in conference rooms, you had issues of throughputs which weren't very good. And I mean, so Wi-Fi has always been this, okay, I wouldn't call it leftist, but chaotic kind of CSMA CD, right? You want to say anything, you just go up and say, I don't care, I'll listen a little bit. It's a little bit more polite. You say you listen a little bit, and then if you don't hear anybody, you go ahead and talk, and you may collide, and then you'll back off and things. So it works very well when the traffic is low, but when you go to higher traffic, you kind of have congestion and things.
Sounds like the standards meetings.
It sounds like a standard, yes. Very much like a standards meeting, but yeah, so then Wi-Fi 6 came around pretty much in 2019, which is taking a look, which the main thing is it was handling densification. So it's taken in a lot of things. So now if you look at Wi-Fi 6 and you look at, from a technology perspective, look at LTE, a lot of the same concepts of scheduling, a lot of the things about, okay, I want to kind of have a more orderly conversation over here. You will talk when I tell you to talk. I mean, that's what this whole scheduling came about. And so Wi-Fi 6 has got pretty much, it has got two modes, one in which you just listen and you speak after that. Otherwise, you kind of have this, you'll talk when I tell you to talk, and the access point controls that. So, and now 7 and 8, we'll talk about. 7 is come out this year. 8's going to, they talk about coming out in 2028. And that's a lot more about getting determinism. So, and that's what, trying to get your network to be under 1 millisecond. Things like in cellular, which we call URLLC, ultra low reliability. So technologies are looking very similar in the way of handling situations, because they are landing with similar situations, except either on a micro basis or on a macro basis. And that's been pretty much the main differentiation, is Wi-Fi still only works in unlicensed band where you've got power limitations, and cellular primarily works where you're in a macro place where you've got a lot more power. And even when we come to private 5G, you can work at a higher power in private 5G. So that's where we are with Wi-Fi, with an overview of that.
Yeah, and speaking, from the perspective of like thinking of value, evaluating these portfolios and these technologies, it's important to keep that distinction in mind, like licensed, unlicensed spectrum. We'll talk a little bit more about that, but maybe I invite you, Raj, to first, and then Mang, to talk a little bit about the differences between these types of technologies, cellular and Wi-Fi.
I think I like to classify people into two categories, radio heads and net heads. So I'm a net head. I think Irfan or Lorenzo, I put them in radio head category. So I'm going to give you a networking perspective. If you look, I think Irfan is absolutely right? Wi-Fi is evolving continuously. If you look at the file layer, the radio layer, they're coming together in terms of sharing bands, using same kind of frequencies, increase ranges. Wi-Fi is a lot more increasing in range, increasing reliability of connectivity, security. So I think those parts are coming together. So one of the debates is the convergence of these two technologies possible or not. Right? So if you are a iPhone or some smartphone holder, you really don't care which technology is being used to access. So I call it really the problem of steering, right? I'm on a phone, I'm an end user, I want best network to be selected based on the environment I'm in. If I'm outdoor completely, like Irfan said, so-called macro environment, I might simply use a cellular service from a third-party service providers. But as you come closer to the, say, just outside a building or in a campus environment, you have a choice. You can steer between either Wi-Fi or 5G network, depending on which network is the best. So that's the problem of steering, which if you get the convergence right, I think given that similar radios are being used, MIMO kind technology is being used, you have people looking at a particular quality of service, you should be able to be completely agnostic about which network technology is being used. I think that's the dream that people have. We are not there yet, but today I think it's possible to think about being able to not steer between the two networks, but switch between the networks very transparently. And 3GPP interworking group, for example, non-3GPP interworking function, those kind of things are beginning to enable in a neutral host environment that these two technologies can work together seamlessly, and we switch between among them. That's how I look at it, as technologies coming together. There's nothing from the networking perspective or end user perspective that should prevent us from bringing these two technologies together.
Mang, any thoughts about this convergence?
Yes.
Oh, you don't have, you might want to just use this. I have my own mic.
Oh, okay. Yeah. Hello? Hear me? Just before I start talk about this, one thing, because you say about Radionia, I want to add it a little bit because Irfan, is that correct? Your name? And just found out he worked for Motorola infrastructure, and I worked for Motorola mobility for 20-some years. Yeah. So we are like, between me and him, we cover the whole cellular, right?
That's what happens when you work in the industry too long, isn't it?
Yeah.
You work with somebody at some point in time.
But very unfortunately, he went to Wi-Fi world. Anyway, so I think there are big difference between Wi-Fi cellular is really the mobility, I think. Lorenzo will totally agree. So Wi-Fi is fixed. You cannot go too far. Then you lost the coverage and you cannot hand over. But for data, it's okay because you don't realize you go to another kind of access point because you just stop transmit. But for a cellular, we have a handover. It's always, that's why cellular is about. The mobility control is a big thing in the cellular standards. So it covers from paging all the way to, handover and all that stuff. And regarding the, Qualcomm and the Motorola, there was a story I would like to share about mobility because Motorola used to work with Qualcomm to solve Qualcomm chipset mobility problems because we have cars going around to identify where, the code got dropped. So then we'll say, hey, there is a bug in your chipset that, cannot handle that. Anyway, that was the story. The second thing is in cellular, we have LAA, which is not a cellular to Wi-Fi switch, but it's more of when you say steal, we try to steal and license the band to have our cellular service. But it's never been deployed so far, as I believe. But I agree, we were converging together. I think it might be some sort of the 6G target about how to use the unlicensed bands, along 6G, with what? Yeah, 6G, right? Okay, that's all I want to add.
Thank you. So let's talk about what's coming. So, Lorenzo, I thought I'm the mild-mannered economist on the panel, but you were very gentle about, well, 5G is kind of a continuation of 4G. I would, sort of ask you to elaborate a little bit more, because the way I think about it, and I want to just talk a little bit about, what is 5G, what are the key features, how is it different from the previous Gs. It helps us as economists to, again, think about the valuation issue and others, and also to keep an eye on the use cases that are coming in the industry. The way I think of the big divide between the previous generations of cellular right now, I'll talk about Wi-Fi in a second, and 5G, is that we really went from the world of connecting people to people to the world of connecting things to things everywhere. And that's a big shift, and it's probably just at its beginning. Your thoughts, Lorenzo, what are the key technology features of 5G? What is it designed to do?
No, yeah, I agree with you, and I would take it even further. I think there's been this big shift with 4G, 5G, where talking about value, these technologies have enabled additional value on top that otherwise would not exist, exactly talking about mobility. So earlier on, cellular technology was just enable basic connectivity of voice calls through cellular operators, and the devices were only meant to have basic data, SMSs and voice calls. But then once the devices became computer, an entire economy started on top of 4G and 5G that otherwise would have not existed. In fact, while the colleagues were talking, I was remembering a presentation that I gave at the 5G workshop in 2015, where in fact I was trying to make this point in 3GPP, that on top of 4G, we had created a whole app economy, and in 2015, already there were estimates that the entire app economy was bigger than Hollywood, which at the time seemed almost exaggerated. I think by now it's completely accepted that even fractions of the app economy are bigger than Hollywood. Or just maybe one app is bigger than Hollywood, and there are multiple apps, each of which is bigger than Hollywood. So this goes to the valuation point, because these technologies have now become enablers of entire new values on top. Now, how does this evolve into 6G? These, exactly because of this great success of these technologies, what happens is that there are basic what I call building blocks. You can imagine these technologies made by Lego bricks. So you have a certain ability to do processing or to access the spectrum or to do mobility. And people try to recombine these building blocks to enable some new use cases. So these new use cases, for example, are, to the point of the earlier colleague, try to have better fixed wireless access. So to drive this sort of convergence between Wi-Fi and cellular for accessing internet indoor, providing better access in industrial applications. So you can imagine in a factory there's a lot of wires, replacing all of the wires with wireless, or bringing wireless internet in areas where it's difficult to bring fiber optics. Because the US is a very large country, it's very difficult to bring fiber optics in the suburbs or large parts of the country. So now people use wireless technology, cellular technology, to bring an equivalent of fiber optics. It's the so-called fixed wireless access or consumer premise equipment. So these are some of these use cases in replacing wires or complementing fiber optics when you cannot bring fiber optics somewhere, which sometimes are a little bit less flashy, but they also create a lot of value. A third one that is really, really big, and to your earlier point, intersects with technology, geopolitics, and so on, is a satellite. Because of advancements in ability to launch rockets, there's everybody probably has noticed, there is a renaissance in satellite technology, which now is much easier to launch satellites into space. And and now people want to use a satellite as a technology, as a complement to terrestrial connectivity. And then you can say, okay, what is the wireless technology between the satellite and devices on Earth, be it people or devices? Again, you can use variants of these building blocks. That also will be a component of 6G. So these are some of the examples of how we are going to go from 5G to 6G. Again, unpacking the building blocks and recombine them to do things that today are not possible.
Mang, you want to add something?
Yeah, you asked me to talk about the technology features in 5G.
Let's do that.
So I'll get a little bit, it's a little bit fair. There are technologies, I'm the patent person. So anyway, I really like to talk about it. So thanks, Lorenzo was talking about the 2G, 3G, 4G, 5G, so the migration, and I experienced all of them. So actually, in the cellular world, regardless of which G, the whole, there are objectives, three ultimate objectives we are looking for. One is a high data, high capacity, and the low latency. So these are the subjectives we want to achieve. So each generation will set the goals for what to achieve. So for 5G, the goal was setting for up to 20 giga, data rate and 1 millisecond of the latency. So did we achieve that? We can look at the very current GSMA, I think it's GSMA report on that. So I think they reported on average, the current deployed 5G system, the downlink is about 233 megabits per second, and uplink is I think it's 40 something. 40, yeah. It's 40? 40, yeah. Yeah, 40. No, not 40, 80.
30 to 40 or 30.
No, 90. I write it down.
Who cares about uplink?
No,
Uplink is how
no. It's
your device is
only 24. It's only 24. But compared with 4G, it's a lot because we are about the 4G was only 44 up downlink, and I think it's 16 uplink on average. It's not the highest. 10 giga probably is the highest. Anyway, so I wanted to talk about this is because it can tell the difference between 5G and 4G. At least the downlink, it's really a big change. So what are the technology really enabled that? So if you look at the very beginning, as Lorenzo was talking about user case, he's very high level was talking about that. I was going to a little more detail. It's about, so there are three most user categories that we are looking at before. The first one is the EMBB, which is the enhanced mobile broadband, because the very easy to understand our bandwidth is increased. So in that category, not only the technology enabled as not only the bandwidth really gets wider, it's more of the flexibility, how to use that bandwidth becomes more flexible and adaptable. Mm-hmm. So we have the flexible frame structures, we have the adaptable kind of band assignment stuff. Mm-hmm. And also the MIMO technology is really improved. So 4G has MIMO, but it's quite limited. But the 5G introduced the beamforming, which really is more targeting for beamforming, right? If you know the technology, it can be largely improve the speed and also some of the capacity. And the second use category is the MTC, is the massive machine type connectivity. That will carry on to 6G, and we don't see too much of a usage on that. So it also relates to if you're setting the goal, setting the use case, you will think about if the market will accept that. So I think 5G still have at least 5 years to run, if it's not more, because the user case like we looking into is more of like smart factories, smart hospitals, smart a lot of things. We didn't really. You don't see that in the market. There are not many of them. They are implemented. So even we were talking about going to 6G, 6G may be create a technology also targeted in this area. Maybe we will talk about it later. But still, 5G will be still going on to implement all these capabilities. I can see one thing is really happening in 5G. It's really affect everybody's life is the streaming video. If 4G, if you stream a video, maybe it got stuck somewhere. But 5G, like the what is it called, TikTok or something? I don't use that often. But you can. A lot of people, like yesterday we had dinner, they were all talking about they use it very often. I said, why didn't you use it? I'm kind of old. So, I think all of my kids, and they cannot leave the mobile phone light. They're all using the video stuff. So another very, very important area is somebody also mentioned is ultra reliability and also ultra reliability and the low latency. It was very much, lots of technology are in it. In the 5G implementation was enabled that. So also like carrier aggregations implemented and the dual connectivity stuff. All these mechanisms enable that happened.
Thank you. Let me just quickly do a translation function for those of us who are not engineers in the room. So I think basically three big things, right? Enhanced mobile broadband, in other words, extremely high bandwidth. So, think your AR, VR glasses, Oculus, things like that. The other is when you said extremely high reliability, low latency, very hard to get that together, meaning you can send extremely short bursts of data very, very fast with high reliability, meaning you can count on it. It won't be dropped. So urgency use cases, sensor trips in an electric grid, you want to send something and it will immediately make it to the control system thing, those kind of use cases. And then extremely dense networks, meaning not just your standard use cases like Lorenzo was saying, we've seen a lot of uptake in the cars and automobiles, and I'm dying to know what you guys are going to see beyond automobiles in the IoT and other kind of use cases for these technologies. But let's get a little bit more of a voice from you, Raj. Yeah. Did 5G deliver its promise? What do you think?
You're setting me up. So to be candid, right, I think the technology evolution from generation to generation in GEs is amazing, right? Mang, really, she tried to verbalize it with respect to what are the improvements have happened. But if you look at the 5G promise, if you're a service provider, of course, you have a captive market. You continue to charge people for mobile subscription, but they have not been able to charge more for 5G compared to 4G because the use cases did not pan out, as far as I'm concerned. Right? We were talked about slicing in the context of 5G. That was going to make it possible to have very different assured services for different types of use cases. Right? We
slicing of spectrum, so dividing spectrum.
So dividing the spectrum and allocating it for different use cases, so you can provide a very guaranteed, high quality, high reliability service. That promise was there, but monetizable services that people can actually deploy and make money have not happened. So economics of 5G, if you talk to the service providers, they had to spend a lot of money on infrastructure, and they can still monetize using the mobile subscriptions, but that's not enough because I'm not paying more from 4G to 5G for my same data subscription. So I think this is where 5G has fallen short, and we are going to 6G. Of course, we continue to march in this 10-year clip. But the question is then how do we also catch up? The two other points I wanted to make to what Lorenzo was saying, we should not forget that Wi-Fi is one of the example of disruptive coming from the below kind of technology. Continues to get better. If you look at 6E, we are in the same bands as cellular, right? Yeah. So in terms of reliability, providing longer range, security, Wi-Fi 7 is going to catch up. So I think that I hope that the industry looks at these two parallel streams and tries to bring them together to be able to create monetizable services, M2M, that machine-to-machine communication that Mang talked about. Again, that's a promise that has been left on the table in mobile.
That's interesting. So, Irfan, to you. Yes, so is it true then that, most of the features that Mang was describing, for example, right, extremely high reliability, low latency, very high bandwidth, Could there be convergence, and the only difference between cellular and Wi-Fi then that remains is mobility?
So, I mean, in some way, the way we look at it from Cisco, and this is, I mean, we always say 5G or 6G and Wi-Fi best together. I mean, there are going to be places where Wi-Fi works very well, and there is going to be possibly the replacement kind of doesn't come into question in some cases, but there are other places where Wi-Fi has limitations, where 5G and private 5G, for example, and continuing that on in the enterprise space is going to start playing a bigger role. I mean, and that's, I mean, in some way, I kind of agree with Raj. If we do look at 5G for the end consumer, it's not been, there hasn't been a new application that you kind of, when you look at your phone, you feel a big difference between 5G and 4G. And that's where most of your 5G today runs on your 4G core network. I mean, the radio is still different, but it's running on 4G core network and getting it there. It's not that the features aren't there, but the use cases that are coming on, there is still time for that, for it to take into place. And that is where we are seeing a lot more play of kind of making 5G technology more applicable to the enterprises. I mean, that's the one place where I think 5G and the core network for 5G can work the same way with when 6G come in. If you really talk to some of the operators, they are kind of saying, we've gone through the 4G to 5G, we have done a lot of the investments, we have a core that works well. When we do go into 6G, let's try to leverage some of these things. And that's where some of these discussions are coming in because, I mean, as Lorenzo said, I mean, a lot of these Gs come in 10 years because it's a play by the operators to get licenses, right? I mean, the license cycle is a 10-year cycle, and so operators need the bandwidth to serve more and more customers. They get it. The new use cases take time to come in, and that's where I think that's where people saying 5G has been a failure is kind of they're not looking at for some of the use cases that 5G is coming in has been designed for is still taking some time for it to come in, and it'll mature, and that's the point.
Yeah, so thank you, Lorenzo. I want to ask you a specific question too. So thank you for bringing up this question about the use cases. Yeah. I want to come to you. So can I ask you this quick question though? That Irfan mentioned this question about the use cases, and Raj was also saying, well, the use cases aren't really quite yet there, and Irfan saying, well, the use cases take time. And the reason I'm interrupting right now is because I read last night fully the very important court decision recently, Nokia versus Oppo decision that comes out of a Chinese court in Shandong. It's an important decision because it's the first one from China that tries to set global licensing royalty rates, FRAND rates, but also it does more. It tries to do sort of this analysis of what's the value of 3G over 2G, 4G over 3G, and 5G over 4G. And very interestingly, it actually says that 5G's value is lower than 4G overall because the use cases aren't there, looking at how consumers are using it. So I want to ask you, I've been thinking about this question, is that the right way to think about this? I mean, where are we in terms of 5G usage, and where are we headed? Does it just take time?
No, well, I'm not going to start commenting. I also read the decision because I'm not going to start commenting on the decision. They're changing the pattern. But the question is good.
Yeah.
And I get asked this question a lot. And I think it's much more nuanced than it seems. So, first of all, in terms of whether the 5G standards has been successful or not, you always have to ask yourself for whom. And, I think it's a fair point that for many cellular operators, it's been complicated. Whether it's because of the technology or because of structural reasons related to the cellular operator business can be debated. Right? Still, you would say, operator like China Mobile is thriving, has millions of base stations deployed, more than the whole North America and South America combined, maybe more than the whole planet combined. I'm not even sure. So
5G base stations.
Yeah, so it's not. It has to be, in that sense, it has to be nuanced. There are several companies for whom 5G has been very good. I think at least 2 out of the 4 companies on stage have benefited from 5G, right? So your company, my company. MediaTek has benefited from 5G. Apple has benefited from 5G. Samsung has benefited from 5G. This is so these are major companies on the planet. So it's very nuanced. Yes, and cellular operators is being more difficult, but I don't think it's because of 5G per se, because there are other companies for whom it has benefited. In terms of the use cases, this is also a good question, because many use cases have materialized them. Let me make you 2 examples. I think I try to be a bit contrarian, because I think it's an easy rhetoric in the last few years about 5G use cases not materializing, but it's just in the face of reality. So the industry has worked a lot on what is called V2X. You go in the US, there is a spectrum for V2X. There will be a aftermarket device.
Vehicle to everything.
V2X. Also, I apologize. Is car to car, is again using the same building blocks derived from cellular technology to have a car to car communication, which you can imagine as a sort of another sensor similar to radar or LiDAR for cars to detect each other. So eventually all those things would go together, radar, LiDAR, cameras, and V2X. Then they get used by cars to detect each other. In China, V2X is deployed. There's another one that I like even better. Somebody was mentioning about the so-called MMTC or massive IoT market not being very successful. Also, this is very arguable. I was in China maybe 2 weeks ago, and in fact, it was very interesting because somebody made this point to me in a China office, and what I responded, just literally outside the office. I don't know if anybody has been to China recently. I hadn't been to China since before COVID. Of course, there are massive amount of bike sharing. Maybe people have seen on social. Unfortunately, here there's not so much, but even where I live in Europe, there's a lot of bike sharing. But in China, it's massive. So you go outside of an office building, and there are thousands and thousands and thousands of shared bicycles, right? You just go there, and you have a subscription, you take a bicycle, and you bike somewhere else. And they are all connected with massive IoT. If there was no massive IoT, there would be no shared bicycles. They just would not exist.
Raj is chomping at the bit.
To that, if you don't mind.
Yes,
yeah,
go for it.
China is not a good example because China ecosystem is a very protected ecosystem, not subject to market forces that we experience here. The funding for companies, they can operate at loss but still be funded by banks. You can't operate like that in US or Europe. The use cases you're talking about, vehicle-to-vehicle communication, is not happening here because of the market forces. Right? I have a Tesla. A lot of people drive Tesla with fully self-driving cars. Are they communicating with each other using V2V? No, because I think ultimately the cellular operators who provide the service have to enable this vehicle-to-vehicle communication and still make money. That's the limitation. Same thing about shared biking economy, right? Of course, China is an exceptionally successful case because it is a huge market. But the economics of providing the service is very different than a free market societies that we have.
Okay, can I add on a little thing?
Sure.
So I just see an announcement about Cisco successfully signed a contract with It's really about the MTC contract. MTC licensing program. So there are some success there. Even the licensing is kind of successful now.
Yeah, but I think unless it's widespread success, at least you need to have the scale. I do believe that 10 years from now, when we visit 7G, some of these things will come back to roost because people will have to address those. Right? I think either the cellular operators have to address those, or the Wi-Fi 7, 8 will catch up. There are multiple things that are going to happen, in my opinion. Ultimately, I'm not an economist. She's an economist. She can tell. Economics will drive this.
So, go ahead, Lorenzo.
No. But I agree with your point. I just want to say there are shared bicycles even in Europe, and it's a somewhat different economic system. And but my point was just different. I found very ironic that. Somebody in China would tell me that 5G use cases are not successful when outside of their own office, literally, there was an example of a 5G IoT in the tens of thousands. And so I think it goes into a bit easy rhetoric that people have read it somewhere is not successful, so they just repeat it in front of you. Even if outside of their office there is a...
Okay, well then let's look at the data. So is there data for, let's say licensing revenues or something that tells us a little bit more about where most of the revenue for 5G use cases is coming from mostly from smartphones? What's the rise? What does the increase look like in terms of licensing or other kinds of data? I'm curious to hear. And by the way, everybody is welcome to participate. I should have said that earlier. We would very much want to have a conversation in the room, and I'll open up the floor for Q&A soon. But is there data that can tell us a little bit more about how the use cases are beyond smartphones are rising with the use of 5G, auto, IoT, or others? What does that percentage look like? Anybody?
So far, I only know one licensing signed for the MC. I think more for NBA IoT devices.
So that means it's early days then, right? I mean, to Raj's point, it's not sort of large scale.
They are still, going on for the bike and the application. You are right. China was the first, because NB-IoT is so hot over there. Actually, I was working for ZT, so I know a lot about how the NB-IoT development over there. So, and also for the meter devices over there, they are all used for that. The meters. So it's meter's huge. Every house has a meter.
Yeah, but I think there are examples of licensing programs around automotive. Of course, largest amount of licensing market remains in smartphones, because of course smartphone is one of the most expensive things a person is going to buy, and everybody has one. So it's just very difficult to compare with the smartphone market worldwide. So that percentage comparison will probably for a very long time be in favor of smartphones, but there are examples of many other licensing markets around cellular. So automotive, I think, is the first one that would come to mind.
Yeah, so you see the conundrum though, right? Like, so when we think about our valuation models, right, like we're thinking about, okay, it's nice that companies are benefiting from it, good for you, and for me, I'm a shareholder. But really, we are thinking about the question of, how are users benefiting from the usage of this technology? And there are two stories here, right? One is that, we can argue fact, rhetoric, but ultimately we need to look at the data, right? So one story here is that it's happening slowly, and it's going to take time. And it's early days, like Irfan's story. And then there is another story that, I don't know, did all these engineers go and did the very complex system and...
I mean, in some way...
We can basically just use Wi-Fi for those use cases?
In some way, I mean, the connected car is a pretty big market. I mean, it's not V2X. It's not what... It's actually what we have done is taken the macro network and modified it to work with the car. I mean... Cisco provides the core network for all of the Tesla communication. So it goes through AT&T, but it kind of is hosted on a Cisco network at the end, and we manage that. So we are seeing a lot more connected cars, as we call it. We are having a lot of smart meters is another kind of applications. But there, as Lorenzo was saying, it's how much dollars are you going to, what that end device costs, right?
Yeah.
In smart cars, if you're connecting the car, it's pretty much the same as what you're probably going to get on a smartphone a little bit. But yeah, so there are device communications which are happening.
Yeah.
Are they using the parts of the specifications that are created for it, or they're not? In a lot of cases, they're basically using the same chipsets that are being made for mass communication, but just kind of modified for or used at lower power or smaller form factors for these devices, and so we are seeing those use cases grow.
Right, expanded market for the similar. So quickly then, before I turn to 6G, I'd just quickly like to get a real sense also, because this, similar to the valuation question, right? Like while we are grappling with, okay, the use cases are taking time and all that, there is also a story of complexity, right? And that's another way to look at the data. We don't have enough or limited use case data right now because of where we are in the evolution of the technology, but we do have data for how the standards, the industry has evolved, right? Like many of us went to standards meetings, we talked about this, and we used to have a certain composition of companies in the room. There were always a few hundred who would come and participate in the standards meetings. And I guess, maybe we quickly start with a very, very brief tutorial on how does the process work. Lorenzo, standards meetings process, and then maybe Irfan, I'll ask you about how has the composition changed, in the evolution to sort of explain, are we seeing a change in complexity? Are we seeing a change in the kind of players that are coming to the table, and how much and in what way?
Technology standards meeting, the main characteristic that I like to always highlight is a mixed process of collaboration and competition. So there are usually all of the players of a certain ecosystem that can be partners or can be competitors. They all collaborate to the development of a new standard because they all benefit from the advancement of technology. So the fundamental principle, this is true for cellular, but it's true also for other segments like Wi-Fi or even video, is collaboration/competition. So we agree with each other that we all benefit from going from here to there. We may disagree, going from here to there, we have to go left or go right, but we all agree we want to go there.
Sometimes those disagreements can get pretty hot. We have had, Lorenzo and I have had some evening discussions after the meeting, but then next day morning we've been together.
Yeah, of course. And so I would simplify it really from this point of view. So there is, of course, every organization is its own process. There are these terms called stage 1, stage 2, stage 3. For the development of the specifications that Tim was mentioning earlier. And so there is a kind of a top-down process where you start to say, okay, what do we want to do in general? And then you start to discuss what are the enabling technologies to achieve that goal. And after you agreed on the enabling technologies, you write the actual specification. And those actual specifications are the ones that Tim was mentioning in his introductory keynotes. And this process has not changed from the early days to 2G to now with 6G. It has just gotten more complicated at the growing of the industry. So this is an industry where maybe at the very beginning there were a dozen or a couple dozens of companies. Then 10, 15 years ago, at least in 3GPP, there were about 200 member companies. And now I think there's over 500 member companies. 500 member companies is a lot. Some companies are sending to these meetings dozens of people, hundreds of people. So
it's a major investment, and complexity is growing.
I agree with Lorenzo. in some of the way, if you look at what the trend I've seen in the number of people coming, and actually in some way the sharing of power in the standards has become a lot more spread than what it was before. I mean, so when I look at, I started off when 4G was coming in, there were a few major companies which could decide, and operators which could decide which work items would be approved or not. And it was a lot of it as to kind of, there was a much stronger filter at that time during the 4G days than when I saw in the 5G days. And I've seen, because I think also the interests of the operators are very, very different than what it was, than the controlling operators before in the 4G days. So that has moved quite a lot as we have seen the G's progress.
Very quickly, by the way, and types of companies, how has that composition changed?
I have something to say
about
the changes. So I think 2G, 3G, 4G, 5G, the changes are coming from the regions first. Used to be only US and EP, and coming to Korea, Japan, join the 3G. A lot Japanese, Korean company join the 3G. 3G all going to 3GPP, then all over the world. But still, there are regions mostly dominated are US, EP, and Korea and Japan. But for 4G, Chinese start to come.
That's really good point.
So there are a lot of Chinese companies, and not a lot of Chinese, probably only 2 Chinese companies are coming, cellular companies coming. So 4G becomes China added. But now 5G becomes Chinese, kind of dominated. The Huawei, they are so having a lot of voice. Or I work for ZT, but I went to in the very late stage, and there are so many contributions out from Chinese company, and actually Korean are still there, but Japanese kind of leaving the mobile domain. 6G, there are a lot more. And also for the people coming companies, as you are asking companies.
Yes.
So at the beginning, it's all dominantly like the telecom companies. Mm-hmm. So later, there are companies like Apple and Intel and all these companies coming too. And also then there are more companies coming in. We will see like the car companies, the automobiles coming. So it's all because they are utilize the cellular standards, and they know they are going to pay royalties. Then they are trying to come and try to make certain contributions. But the one thing I want to point it out is, so far from the data, I think, I always see the most contributions or most accepted contributions are still from the major cellular companies or cellular research companies like Interdigital, right?
So I want to come back to that. That's a very important point on the evolution, regional evolution. But we have a question from the floor, and I was wondering, Tim, if we can organize a mic. 2 questions.
My question is this: what is the status of the 5G deployment? Because what I heard was that the deployment of true 5G standalone is still fairly low, 15, 20, 30%. So related question is that we don't have use case for 5G because we don't have full deployment of true 5G, or we don't have use case for 5G because we just don't have it.
Or it's a chicken and egg problem. Was there another question? We'll take 2 at the same time. Please go ahead. Okay.
I mean, in some way, it is region dependent also, so I'll kind of qualify it with that there are certain regions where 5G, what we call standalone, has been deployed, and there are other regions where 5G standalone is still it's deployed just by a few operators and not by all of them, right? I mean, in United States, the biggest 5G asset deployment is T-Mobile, and that is a standalone that uses the new 5G core. But a lot of the other operators are still doing 5G using the NSA model, which is using the 4G core, but the new 5G radio. So in some way, the transition of the core from the 4G to 5G is still happening, and some of it is happening or is taking some time is because, as you said, there is a cost involved in that transition and the use cases. And in some ways, if you're able to get the use cases done by NSA, it takes away the impetus to move to SA in the time frame. So
yeah, go ahead, Raj.
Yeah, so I do believe that 5G is not as prevalent in US especially. T-Mobile is, of course, trying to be number one provider, so they have economic incentive to go 5G standalone. But 5G standalone itself, I think, does not have the economics behind it, is the point I was trying to make. There are no, analogy I'll give you is the cable service. Wherever you have two cable service providers in US or Europe also, you're not paying more when you went from 100 meg to 200 meg or 300 meg. You're paying almost the same amount of money. Because just faster speed or faster throughput, of course, there they at least have OTT streaming, right? Or the top streaming services for video services, so you can justify higher cost. What is 5G enabling beyond 4G in terms of use cases is still not clear, in my opinion, to justify making money. And if you can't make money, you're not going to put in more infrastructure.
I have a question for Jay. I heard that in the 6G development now, people are talking about eliminate the, not eliminate, just want to have 6G standalone. Did you hear about that?
Without backward interoperability? Yeah, I think that's a great approach to take. It might lead to either one of the two outcomes. 6G will not happen because of that, or 6G will really replace all the previous Gs. I think
it's not that they do insist 5G and 4G. They will go on 5G, but there's no back, going to a two
interoperability, backward. But I think
it's still
like
compatible
Apple and, I do believe that companies like Apple and Samsung will make that decision, because ultimately they have the market power. They are really the vehicles for all these technologies.
So this is super interesting. So let me just quick translation function for those of us who are not engineers. So when we talk about standalone, I'm sure it's obvious for most of us in the room, but if it's not standalone, it means that we're just talking about 5G only infrastructure without backward compatibility with 4G and 3G and previous generations.
I don't think so.
No, you have backward compatibility. In the sense that you can carry the 4G traffic over it, but you don't have 4G core anymore, just a 5G core.
Thanks for that clarification. But it's just explaining what standalone is. Lorenzo, you were going to say something?
No, yeah, I think a colleague from Interdigital made a very interesting point earlier that because we were talking about this explosion in participation, which of course is being a sign of success of the organization, that now there are hundreds and hundreds of member companies. And since you were talking about data, and we are hosted here by Tim, that is the master of data, it's also interesting to notice, and a colleague of mine has published a paper in that regard, that from the beginning of 5G, there's been a few hundreds, thousands of standards contributions, and about half of them come from 6 companies. Vast majority of them come from 20 companies. I will not remember the exact figure by heart, but this is the ballpark. So it's very interesting that on one hand, there are, I think, over 500 member companies, because people want to participate and understand. But in reality, then the technology is designed by a very small minority of companies, and those are the ones that really drive the technology. And depending on where you put your cutoff, you are either in a number of companies that more or less can fit in one hand, or maybe about 20 companies. You can expand it to 15, 20 companies are the ones that really do the work.
Yeah, so basically, that's an important point. And I think for the next panel on licensing, litigation challenges, this is going to be more relevant, that when we're talking about sort of this increasing complexity through the Gs and increasing number of companies coming in, it's still sort of this, within at least the standards universe, this innovator-implementer mix where the distribution is extremely skewed. Very few that are investing this early on R&D and contributions, and a lot of people trying to identify the use cases and implementing. And Tim, since you're the data person, we don't have this answer yet, right? Like, how are the use cases evolving and what's happening? But one way to look at it could be to look at the changing in the composition of companies that are coming to the meetings. So, like, why are they coming? Because there's a possibility of certain use cases happening, at least now or in the near future. So that can give us like some sense of evolution on how that's moving. So where were we?
I'm going to jump across Christine. I think you were first.
Decision between Nokia and Oppo is mentioned. I just want to clarify that the value of 5G is low in that case, not because of use cases. It's based on a very particular report which measures what's the incremental value at that existing point in time in a smartphone, in a smartphone, so in respective of use cases of 5G over 4G. Yeah. And I think, well, unfortunately, that report is not available. I would very much hope that it's available for everyone to discuss. But one of the relevant questions is this: when you're looking at the incremental value, do you measure the percentage by the value of a 5G phone, by a 4G phone, or a hypothetical phone that is completely equal in all the other features except for connectivities, right? And my view is that it should be the middle. And the second point is that decision is vacated now. And if you look at, interestingly, like if you look at the Supreme People's Court's list of top 50 cases, it's not on the list. And also, if you ask the leading experts in antitrust and in SEP in China, they will tell you that it's a very specific case that is unique to its circumstances and policy. So just want to set the context of how China view that case.
Quick factual question. Nokia versus Oppo decision is not vacated.
It is vacated, yes. It is vacated at initial, so.
Okay, good to know. John is nodding his head, so what's the status right now for the audience? Because at least as far as we've been informed, and it's sort of the dispute settled, the case is vacated. I see. So, but the decision's still out there. So, okay, I see. So, thanks for the clarification.
Perhaps.
Okay, so any other questions from the floor? 2 questions.
Hi, sorry. So I wanted to ask we talked about standalone and non-standalone, right? So the 5G radio running on the 4G backhaul or running on a 5G core, right? And as I understood it, Matt Noble, Bird and Bird. As I understood it, that when I was looking at this 6 months ago, the proportion of rollout of the standalone network was very, very small, smaller than the sort of 20 to 30% that we talked about just now, but maybe it's gone up. But what I understood is that another serious hurdle or impediment to the promise of 5G is not 5G running on a 4G core, but the fact that the spectral efficiency of 5G is predicated on the rollout of millimeter waves, right? And so, for example, I went to a great stand that Qualcomm put on at CES that demonstrated the spectral efficiency on the show floor. And as I understood, the impediment to that rollout is 3 things. It's the fact that not all devices can actually do it. It's the fact that there are spectrum auctions that haven't taken place in certain countries yet to make that spectrum available. And thirdly, there just hasn't been enough investment in creating the microsites that you need for the base stations, because, of course, they need to be a lot more dense in order to be able to reach the phone, because, of course, they don't travel as far because the frequency is higher. So I'd be grateful to know if the panel agrees that it's millimeter wave that has been one of the main impediments to achieving the promise, and if so, are we likely to see a change in that in the coming years?
Good question.
Just one thing I can try to add there is in 5G, the sweet spot has been 3.5 gigahertz. So we do hear about the 28, the FR3, the 28 gigahertz, where physics has a problem, right? I mean, we haven't been able to engineer over the fact that at that higher band frequency, you turn your phone, you will lose your connectivity because of just the radio conditions. So where a lot of 5G radios have been deployed is in the 3.5 gigahertz band, which is just above the 2.6 where 4G is.
Sits.
And there we are seeing MIMO, the ability to have, because the antennas get a little closer, you can have more antennas. And with fixed wireless, that's where some of the fixed wireless deployments coming in the 3.5, where you've got a little, your mobile's a little bit, your customer premise equipment can handle more antennas and get you some of that advantage. So I do agree 28 gigahertz has not been very successful, but 3.5 is where a lot of the 5G SA deployments have been.
Third point is very well taken about density, right? I think we need much higher density, very distributed architecture. And that's where I think I see that operators are beginning to invest because it's very expensive to be able to achieve that. You have to create literally tens of thousands of so-called edge clouds to be able to support that. And one thing I do believe that has to happen, transition from a pure hardware-based architecture to software. Because if you have to achieve that level of density, and if you have to buy these vertically integrated stacks from Nokia, Ericsson, or Huawei, it's very expensive for the operator. There's an alternative that companies like Intel, NVIDIA, and AMD are pushing now, which is use a standard x86 processor with some acceleration for layer 1 technology and do everything in software. That's much, if you look at the TCO analysis, that's 50 to 60% cheaper than the hardware-based approach. That has to happen, and it's beginning to happen next 2-3 years, in my opinion, and that will help.
Yeah. Lorenzo?
Yeah, no, very quickly. To your earlier point, you're asking if people agree. Actually, I don't, but I think people answered you. I think what you said is a very US-centric perspective. I said earlier, wireless technologies are based on spectrum. Spectrum is regional in nature. The allocation of spectrum is different for reasons that everybody can have an opinion on. When 5G came, the US did not have spectrum available where most of the rest of the planet had it, which was 3.5 gigahertz. And therefore, the US was forced to rely on millimeter wave. I'm saying the US, but it's not like a single person's fault. It's just how things went. And then there's been problems. But this is a very US-centric problem. For most of the rest of the world, people just don't care. They deployed 5G in the 3.5 gigahertz band that Irfan mentioned, and life is good. Spectral efficiency is better than LTE. It's just proven. And there's no problem. And you can use the same topology of LTE, meaning you can use the same sites that already exist for LTE, and you are putting 5G in those same sites, and people did 5G that way, and that's how it went for most of Europe, China, Japan, Korea. So, I mean, in that sense, the reason I said I disagreed with you is because what you said is correct, but it's very US-centric. If you look at the totality of the world, it just went different.
I think in the UK we were excited about millimeter wave, but maybe it was mismarketing to expect it to come.
That I wouldn't disagree with, yeah.
So very quickly, where are we? So millimeter wave, 28 gigahertz and above, like high frequency spectrum, where we can use much more bandwidth suddenly. Very complicated. Where are we in its deployment right now, and what do we expect in the US and globally?
I mean, it might take it'll take some time, but I think we have the foundations to kind of for it to come, and to kind of add to what Raj was kind of saying is, I mean, in some way from the core network side, when we look at it, I think there is a play now for trying to have the core such that it is managed and it's provided to service to operators also. So I mean, that's one of the things that we at Cisco are looking at doing is that integrating all these network functions is not a very simple thing, but if we provide it as a service to operators, then that would come in. Now, obviously, this also takes some time for operators to get there. I mean, so initially it's going to be the tier 3 operators and things who are looking into that, because at the one point, I mean, so we at Cisco have, and I'll be frank, we have provided hardware-based solutions and we have provided network function, virtualized functions too. And I'll just say what's written on paper and what you see are different things. I mean, so it's not always a case that you say if you put in the servers and put in the software, you'll get the same efficiency out of it. Whereas dedicated hardware has its problems, but it also has its advantage. I mean, you get a dedicated hardware which is kind of optimized for packet processing and kind of handling the kind of millions of subscribers and traffic. You take it to a virtualized platform. It takes some bit of optimization to get it to the point where.
So quickly distilling, basically, you're saying ultimately the bottleneck again is our network operators going to be able to invest in the infrastructure to deploy the technology, and for that the bottleneck is again, seems to be use cases like you were saying, Raj, like super dense network use cases like in a stadium or somewhere where you really need 5G millimeter wave. And then the other, I think what I'm getting from what you're saying, Irfan, a lot of technical there, is that we're not fully there in terms of the solution.
We're
technically
not fully there,
too.
and operators are. I mean, they're beginning to look at other models for deploying the core network. Is what I'm.
Okay, and then I would like to ask the last question, but first, question from the floor, please.
Yeah, so I wanted to make an observation and then get the panel's reaction on it. So there's clearly, there's the Wi-Fi world, and then there is the cellular world. And over the decades, the cellular industry has sold to maybe a handful of companies around the globe, whereas Wi-Fi is definitely selling to a lot more customers, right, and deployed much more widely. So as things are moving towards more digitization, what implications do you see towards 5G and 6G? Because, I mean, from my perspective, if I look at that triangle that you were talking about there, MMTC, URLLC, and EMBB, those URLLC is not here. MMTC is what? NB-IoT and LTE-M, maybe RedCap coming. So how is the industry going to evolve to? Because when you go outside the industry and people who are looking at it, they say, well, the hype goes so far ahead because you were just selling to a few companies, and now when people from the other world are looking at it, they find that it's not there. I mean, the expectations are there, and when the reality comes, the products are not there. So that I would like to understand from the panel what they think about it, and particularly how standards are going to evolve. Because a lot of times you find that something gets standardized in release 16, but the stage 3 is like 3 releases later.
Everybody got those acronyms right? We'll have a quiz in the end. Thank you.
Let me try to take a first stab at it. And then, so in some way, we are seeing a closer working between enterprise networks and both private and public cellular. And what we are looking at is, I mean, there are a few hurdles. There are things that we've got to overcome and work towards. Is coordinated identities, right? I mean, the identities are very different in the cellular space, or even private cellular, and the enterprise space, which is all kind of certificate-based and things like that. So that we are looking at that integration for sure. The one lesson that we've learned, and I mean, we're looking at 6G as a network of networks. One of the things that we've learned through the standardization is that the tight interworking is not a solution that is going to succeed. So we've gone through various levels of tight integrations, and what's out there today, what works today is just Wi-Fi calling is the one case which is really in a broad scale. So we are looking, we've got to have some kind of loose interworking between them. There are new technologies, there's QUIC, there is mask, those kind of things where it is still a little bit more at the application layer rather than...
So we're going to have to, okay, so I think there are some disagreements on this, but we're just going to have to agree to disagree on the Wi-Fi cellular convergence, because I can't let you guys go. We have only 5 minutes, and I can't let you go without talking about 6G. And we're just going to have to dedicate those 5 minutes to what's coming, what are the features, get us excited or not. That's, we're looking at you now. Okay, Mang, let's start with you.
So there are 6 areas that people are looking at the 6G, and actually some other extension of the 5G, like the experience, the massive machine type communications, and also they now call hyper reliable and low latency instead of the ultra. So there's another name. But these are the continuation.
So not 99.999999%, but 6 more nines.
So it's maybe cover more stuff to use cases. But like this really connected to your question, there are continuation of the technology development for the use cases. So and the other thing is like the immersive experience it's called immersive communications. So they will give you more XR experience in it. So but now it's still not very 5G was developed for that too, but it's not really deployed that much. But we're looking to 6G, right? And there is another important thing I want to mention is really the sensing communication. So the sensing communication is not only the regular sensors you use, it's more of utilize the cellular system to sense a lot of environment. So that is one area. I think that will, because we have so many data around the cellular system. So I remember long time ago, Motorola was proposing, one engineer was having patents proposing utilize all the data around to do, but there's no computation power we can do to utilize them. It's more related with maybe AI coming in. It will be, we can do a lot about network sensing. So that, in my opinion, it can achieve, it probably will apply, implement earlier than the immersive one. It's more about how many people are really going to the immersive world. It's a virtual world. And another thing is about AI communication. And that is, I personally very interested in, because AI will be in every layer to assist our system to be more efficient and generate more accurate decisions. For example, like in the CSI, I don't know if it's a technical word, channel state indication, which will communicate it between basic says in our world, is communicated between the base station and the mobile to see how to assign the channels or to do the MIMO stuff. So that one, if you look at currently the calculation is very mathematic, and also I think it's kind of involve less intelligence. But if the AI join in, and then we can have a better CSI feedback mechanism. This is what I think. So these are, if I'm missing anything here, a massive communication. I talked about hyper reliability, immersive, AR, and
if you
where is the
want, I
last
can
one?
add one.
Oh, okay. So hold on. I haven't finished yet. So the AI joined in the communication, like Interdigital was doing something about using AI to the channel models. So that will be the first step to apply AI to it. But AI will be not only utilized in the air interface, each layer, and also will be utilized in the back system network. Actually, it's already used, I think, if I don't take it wrong, like the ZTE was developing a lot of AI algorithms inside the, the cellular network. I'll give it to you.
Yeah, I mean, I think you covered it very well. The only one I would add that is the counterpart of sensing the environment with wireless signals is what is called ambient IoT. So integrated into the wireless system, also what we could think of as RFID type of tags. So something even smaller scale that's massive IoT. So imagine tags that are passive, they don't need a battery, they just reflect energy from the environment, and then they can be used to have a, let's call it a next level of IoT.
So how are we, Lorenzo, I mean, given that, we had this long discussion about 5G use cases and where we're at, and we're still sort of in that mode of seeing how it evolves. How are we thinking about 6G?
They're inventing new future use cases.
Yeah, no, as I mentioned earlier, all these use cases I mentioned earlier, they will continue towards 6G. So 5G for satellite, for example, is a big one. And there is a lot of interest in various parts of the world in satellite communications. And eventually, there's an interesting thing that the satellite industry is in a similar stage, this seems strange, but it's like that, as the cellular industry in the 80s. Mm-hmm. So you are reminiscing about 1G. Mm-hmm. 1G was very fragmented. There was not a 1G standard. There was a 1G standard in the US, one in Scandinavia, one in Germany, one in Japan, and maybe other places I don't even remember. And I was barely born. So satellite industry is similar, right? So satellite systems use proprietary technology, but because now there is the possibility to use a variant of 5G, soon 6G, into satellite technology, there's a tremendous industry to move satellite technologies to a standard, because it, of course, is more economical. Yeah. So it sounds very obvious to this discussion on this panel, but the satellite industry just has not had this moment exactly ever. So that's going to be a big one, I think, towards 6G.
Irfan, any last words?
Yeah, so I mean, just to say, I mean, we do see a network of networks with Wi-Fi and cellular, but for that we also see that the roaming model has to be fixed a bit, because right now it's all GSMA based, so we are looking at kind of trying to bring in a little bit more federated models that can allow for roaming between networks. Managed platforms for enterprises are going to be coming in more, so that's more of a deployment thing. We are looking AI, as we said. There's been talk about AI and RAN. Of course, you can't finish off without talking. There's AI and RAN and everything, but we've got to be supporting over-the-top AI, right? Inferencing happening at the edge. And that's not just going to be the radio, but also the transport has to be going hand in hand with that. So in order to optimize that.
So thank you for the discussion, everybody. Raj, you have...
My last word on 6G.
Yes.
2 words, be skeptical. I think it's going to be a tale of 2 cities. China, it will continue to innovate faster than the rest of the world. They have the walled garden economy. They can do it. And I think especially Huawei has invested a lot in 6G. But outside of that, I think economic factors will delay 6G by 5 years. That's my prediction.
Or be optimistic. But I think you segued really well into our keynote. But I just want to just thank you, all of you, and by saying thank you to all. And what I heard is that these are very complex technologies. And you guys walked us through the evolution. You guys walked us to where we are at. We had a very healthy debate about, are we seeing the promise delivered that was, maybe, I mean, yes, no, maybe, sounds like it's early days. These are, global technologies. Everything and everybody is connected. Satellites are entering the space. AI is entering the space. So there's lots to do. And we'll keep working on these, building these use cases and valuing and the global issues that arise with it. So thank you again for bringing us along and starting the day with this discussion.
Thank you.